I am Dr. M. Anwar Sadiq from the Department of Chemistry, Jamal Muhammad College. This e-content describes the theory, conditions, and selection rules of microwave spectroscopy. At the end of this module, learners will be able to explain the theory of microwave spectroscopy, identify the conditions required for a molecule to exhibit microwave spectra, and apply the selection rules governing rotational transitions. Now, I will narrate each concept in detail. Microwave spectroscopy is a subcategory of molecular spectroscopy and it falls under absorption spectroscopy. The theory of microwave spectroscopy is that it studies the interaction of microwave radiation with molecules. During this interaction, molecules undergo changes in their rotational energy levels due to absorption or emission of energy. Rotational energy is associated with the rotation of an entire molecule in a specific axis. Rotational energy levels are quantized and transition occur between these discrete energy levels. Microwave spectroscopy is also known as rotational spectroscopy because it involves rotational transitions during the absorption of microwaves. Next, the conditions of microwave spectroscopy. A molecule must have a permanent electric dipole moment to absorb microwave radiation. Condition explained with the following cases. Case 1, homodiatomic molecules. Examples are hydrogen molecule, oxygen molecule, nitrogen molecule, fluorine molecule, chlorine molecule, bromine molecule, and iodine molecule. These molecules have zero permanent electric dipole moment. Reason, their bonds have symmetric electronic distribution. So, no dipole is formed. Therefore, such molecules are microwave inactive. Case 2, heterodiatomic molecules. Examples are hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide, carbon monoxide, and NO. These molecules possess a definite permanent electric dipole moment. Reason, their bonds have asymmetric electronic distribution, creating polarity. Therefore, such molecules are microwave active. Note, microwave spectra are best observed in the gas phase rather than in the liquid or solid phases. This is because molecules can rotate freely in the gaseous state, whereas in the liquid and solid states, their rotation is restricted. Selection rule of rotational spectroscopy. The allowed rotational transitions follow the rule delta J equal to plus or minus 1, delta J equal to change in rotational quantum number. J is equal to rotational quantum number. This pattern only occurs between adjacent rotational levels. This means transitions occur between successive rotational levels alone, that is discrete levels. This is the pictorial representation of total molecular energy level. Here, the rotational transition occur only in the A zone. Rest of the zones are forbidden. Here, delta J equal to plus 1 means this is due to absorption of energy. Molecules gain energy moving to a higher J state. That is, J0 to J1 or J1 to J2, etc. Similarly, delta J is equal to -1, change in rotational quantum number, delta J equal to -1. This is emission. Molecule loses energy moving to a lower J state, that is J1 to J0. Thank you very much.